Navigation aids on the ground enable aircraft to pinpoint their position with high accuracy. Most oceanic airspace lacks radar coverage and radio navigation aids. Aircraft must rely on their own long-range navigation systems. To ensure safety, air traffic control requires higher separation standards in oceanic airspace. Improvements in technology and redundancy now allow approved aircraft to fly with reduced vertical and horizontal separation in certain airspace. MNPS airspace allows reduced lateral separation requirements. RVSM airspace allows reduced vertical separation requirements. Let's take a closer look at MNPS, which stands for Minimum Navigation Performance Specification. MNPS airspace has been implemented in the North Atlantic region within these oceanic control areas from flight level 285 to flight level 420. Organized tracks in the North Atlantic were once spaced 120 nautical miles apart. With the implementation of MNPS, the track spacing has been reduced to 60 nautical miles. This saves fuel and minimizes traffic delays by accommodating greater numbers of aircraft in the most fuel-efficient routes available. Aircraft within this airspace must be able to fix their position with a higher degree of accuracy. The North Pacific region has fixed tracks spaced 50 nautical miles apart. Within the North Pacific route system, the primary form of lateral separation is based on RNP-10. RNP-10 airspace makes a requirement for accurate position keeping, but it is not considered MNPS airspace. MNPS airspace specifies both the position accuracy for the aircraft and sets additional requirements for the carriage of specific navigation equipment. We'll discuss these requirements later in the lesson. Now, let's take a closer look at RVSM, or Reduced Vertical Separation Minimum. Generally, RVSM airspace in the North Atlantic is co-located with MNPS airspace. The dimensions of this airspace varies. In the North Atlantic, RVSM airspace is between flight level 310 and flight level 390. In the North Pacific, RVSM airspace is between flight level 290 and flight level 410. RVSM transition areas indicate where ATC will transition aircraft from 2,000 feet separation to 1,000 feet separation. This transition occurs under radar contact in specified transition areas. In the United States, above flight level 290, the conventional vertical separation minimum is 2,000 feet. As of January 20, 2005, domestic RVSM was implemented. This allows for 1,000 feet of separation. RVSM saves fuel by allowing more aircraft at the most fuel-efficient altitudes. With the reduced separation, there are now 6 new flight levels available for use. This allows for more direct routing, reduced traffic convergences, and less delays. Note that all of the flight levels in RVSM airspace obey the standard east-west rules for cruising altitudes. Flight levels 310, 350, and 390, which were once westbound under conventional separation, are now eastbound in RVSM airspace. RVSM airspace is from flight level 290 to flight level 410. Above flight level 410, the 2,000 feet separation remains. Aircraft and operators that are not RVSM certified may not enter this airspace. Aircraft not certified must specify negative RVSM to the controller before requesting a clearance to climb or descend through this airspace. When domestic RVSM in the lower 48 states was implemented, RVSM in adjoining airspace was also activated. This included Alaska, Canada, Gulf of Mexico, Atlantic high offshore airspace, the San Juan FIR, the Caribbean, and South American regions. The best single-source reference to operations in these airspaces is on the charts themselves. For example, the Jefferson Pacific and Atlantic orientation charts contain most of the information presented in this lesson. Safety is maintained by restricting RVSM airspace to approved operators with properly trained flight crews and to aircraft with specific equipment. These requirements are specified in 14 CFR Section 91.180 and Appendix G to Part 91. Additional requirements for aircraft and operator approvals are contained in Document 91 RVSM. Let's take a closer look at some of these requirements. An operator must have approval from their respective state of registry before conducting flight operations into this airspace. The operator should receive from their Civil Aviation Authority either an approved amendment to their operations specification, a letter of authorization for Part 91 operators, or a management specification for fractional ownership operations. The flight crew must accomplish an approved training course, and there must be an approved RVSM maintenance program also in effect. For RVSM airspace, the aircraft must meet certain equipment requirements. There must be 2 independent primary altitude measurement systems. The aircraft must be equipped with an altitude alerting system that signals an alert when there is a deviation from the selected altitude. The alert activates at plus or minus 300 feet for earlier type certificated aircraft, and at plus or minus 200 feet for later aircraft. At least one automatic altitude control system must be installed. Also, at least one altitude reporting transponder is required. For MNPS airspace operations, the aircraft needs 2 long-range navigation systems, LRNSs. A traffic collision avoidance system, or TCAS, is not listed as a specific requirement for RVSM airspace. However, with the exception of certain Part 91 operations, TCAS is now required equipment for most airplanes and operators. For RVSM operations, if the aircraft is equipped with TCAS, it must be TCAS 2 version 7 or later. Earlier versions are not compliant with RVSM. Finally, ATC must be notified in flight if any of this equipment fails. During flight planning, the flight crew and dispatchers should pay particular attention to conditions which may affect operation in RVSM airspace. Weather forecasts and observations should be examined for areas of turbulence and mountain wave activity. These can have an adverse effect on maintaining level flight. Verify that the aircraft is approved for RVSM operations, and account for any restrictions or limitations that may be related to RVSM airworthiness. Annotate the flight plan as required. The equipment box or item 10 on the flight plan form should be annotated with the letter R to show RNP 10 approval. This is required, for example, when transversing the North Pacific MNPS airspace. The letter W shows RVSM approval. The X shows MNPS airspace approval when transversing the North Atlantic. Other suffixes for regular equipment still need to be shown. Box 3 of the FAA flight plan form is used for equipment suffixes. Operators can only file one equipment suffix. This suffix is displayed directly to the controller. As of September 1, 2005, aircraft equipment suffixes have changed to include additional codes for RVSM aircraft. Aircraft with advanced RNAV equipment, Mode C transponders, and RVSM approval now use codes J, K, L, or Q as appropriate. Aircraft with RNAV and RVSM capability but not advanced RNAV capability will file slant W. During your pre-flight checks, special attention should be paid to maintenance logs regarding airplane equipment pertinent to RVSM MNPS flights. Checking the altimeter system is especially important for flights in RVSM airspace. As always, set the altimeters to the local QNH setting for the airport. Compare the altitude indications with a known value, such as the airfield elevation. Each altimeter should be within specified tolerances. The two primary altimeters should also agree with each other. The maximum height difference should not exceed 75 feet. During pre-flight, make a record of the altimeter readings for use in possible contingency situations. When the left altimeter is used to control the altitude, either manually or with an autopilot, the left transponder should be selected. This ensures that transponder Mode C transmissions reflect the controlling altimeter. Similarly, if the right altimeter is used to control altitude, then the right transponder should be selected. Select the left transponder now. For MNPS airspace operations, longitudinal separation depends on accurate position reports. Position reports are based on UTC time. Therefore, a time check of the aircraft master clock must be made as part of the pre-flight. The aircraft clock must be synchronized to an acceptable UTC time signal. An error of only 1 minute equals approximately an 8 nautical mile position error. During climb, special attention should be made passing the transition altitude to reset the altimeter to the standard setting of 1013 millibars or 29.92 inches. Reset the altimeter. When cruise altitude is captured, or when you are cleared to a new flight level within RVSM airspace, the airplane should not be allowed to overshoot or undershoot by more than 150 feet. An automatic level-off is recommended. Pilots should verify that the cruise altitude matches the ATC clearance received. A recheck of the standard altimeter setting is recommended when reaching the initial cleared flight level. After your initial level-off and while in RVSM airspace, cross-check and record the primary altimeters approximately every hour. They should agree within 200 feet. A lesser value may be specified in the aircraft operating manual. Depending on your aircraft, the standby altimeter may not be certified for RVSM. However, the difference between the primary and standby altimeters should be noted for use in contingency situations. Be sure that you are complying with any aircraft operating restrictions, such as a maximum Mach number for RVSM airspace. Accurate speeds and accurate position reports provide the basis for longitudinal separation between successive aircraft. Maintain your assigned Mach number at all times, including en route climbs and descents, unless a specific reclearance is obtained. Continue to fly your assigned speed after leaving oceanic airspace unless ATC authorizes a change. Transponder settings differ slightly depending on the airspace. See the proper orientation chart for reference. In the Pacific, the standard operating procedure is to squawk 2000 when entering a FIR from an adjacent region where operation of a transponder has not been required or assigned. For North Atlantic airspace, retain your last assigned code for 30 minutes after entering NAT airspace, then squawk 2000. Reset the transponder. If operating in Reykjavik's airspace, they may assign you a discrete code. If assigned, use it throughout the Reykjavik OCA. Now, let's do a quick review of the TCAS system. Recall that for RVSM airspace, if TCAS is installed, it must be TCAS 2 version 7 or later. The alerting criteria has been adjusted to accommodate the reduced vertical separation. However, nuisance alerts are still possible, but can be reduced with proper procedures. If two aircraft are approaching adjacent flight levels in the same proximity, an alert will be triggered if the closure rate between the two is 1,500 feet per minute or greater. For this reason, the pilots should restrict their rate of climb or descent to 1,000 feet per minute or less when operating within 5 nautical miles and 2,000 feet of other aircraft to minimize the generation of TAs and RAs. During flight, the transponder mode selector should remain in the TA-RA mode. For level flight, traffic alerts are triggered at 850 feet. Resolution advisories are triggered at 700 feet. Finally, recall that all RAs must be reported to ATC. Most oceanic airspace requires the use of high-frequency HF radios. Selective calling or cell call is also used And an operational check should be performed when checking with each new controller. When able hire reports are used to facilitate en route climbs, they may be required or they may be optional depending on the Oceanic Control Area, OCA. Pilots should indicate the highest flight level they can accept and the time or position at which this can be achieved. When able hire reports should be made on initial contact with ATC at each OCA boundary. The report can also be added to the end of routine position reports. There are two things to remember regarding the When Able Hire, or WAH report. First, a WAH is not interpreted as a request for a higher altitude. Second, an ATC acknowledgement of a WAH is not a clearance to change your altitude. A separate clearance request must be made. Communications regarding altitude changes in RVSM airspace is very important. Pilots should report when leaving an altitude. And when reaching level flight after making a climb or descent. The only exception is when under automatic dependent surveillance or radar contact. In oceanic airspace, meteorological reports or MET reports of the wind and temperature in flight should be passed to ATC when required. On published airways, such as the North Pacific, the M symbol designates a required MET reporting point. In the North Atlantic airspace, when operating along an organized track, MET reports are only required if your flight is designated to give them as part of your oceanic clearance. MET reports are required on all flights that are not entirely along an organized track. If required, MET observations should be recorded crossing each longitudinal reporting point and midpoint. MET reports are given by appending them to the end of position reports. The format for these is shown on the appropriate chart. Now let's examine the standard phraseology used by pilots and controllers in domestic RVSM airspace. ATC may inquire if you and your aircraft are approved for RVSM operations. The phraseology used by ATC is confirm RVSM approved. The proper response is either affirm RVSM or negative RVSM. If not RVSM approved, be sure to include the reason, such as negative RVSM, due certification flight. If ATC denies your clearance, they will state unable to issue clearance into RVSM airspace. If ATC allows an unapproved aircraft to fly in or through RVSM airspace, the pilot should report negative RVSM for the following situations. In all requests for flight level changes pertaining to flight levels within the RVSM airspace. On the initial call on any frequency in the RVSM airspace. In all readbacks to flight level clearances pertaining to flight levels within the RVSM airspace. And in readbacks of flight level clearances involving climb or descent through RVSM airspace. If any of your required equipment for RVSM flight fails, such as all primary altimeters, automatic altitude control systems, altitude alerters, or transponder, you must state to ATC unable RVSM do equipment. Be sure to repeat this restriction on initial contact to each controller while in RVSM airspace. If you are unable RVSM due to weather, be sure to state the reason, such as turbulence or mountain wave. When clear of the weather or if failed equipment has been resolved, inform ATC. The proper phraseology is confirm able to resume RVSM and ready to resume RVSM. Sometimes things don't always go as planned. Equipment failures and weather may cause you to deviate from your original flight plan. Special procedures for these contingencies have been set up for operations in MNPS and RVSM airspace. Procedures for in-flight contingencies differ depending on the airspace. For RVSM airspace and oceanic areas and MNPS airspace, refer to appropriate reference material. Procedures for the loss of radio communication can vary. Lost comm procedures may be different depending on whether you've entered the oceanic airspace and whether you've received an oceanic clearance yet. In general, here are some things to remember. If unable to reach ATC, attempt to contact other aircraft to relay a message. Tune left VHF radio to the air-to-air frequency. Use the emergency frequency 121.5 if necessary. If all communication is lost, set the transponder to 7600. Remember, at least 2 long-range navigation systems are required. However, special routes have been established if failures leave you with only one system operational. If both systems fail, entry to MNPS airspace is not allowed. If total failure occurs while in MNPS airspace, then pilots should use their best judgment. Immediately notify ATC. Keep a vigilant lookout for other aircraft. Resources available to you include radio navigation aids, visual sightings, weather radar ground returns, and other aircraft for useful information. Three types of contingencies for domestic RVSM airspace are discussed next: equipment failures, weather-induced severe turbulence and/or mountain wave activity, and wake turbulence from other aircraft. Recall that in RVSM airspace, the maximum height difference between at least two primary altimeters should not exceed plus or minus 200 feet. If equipment required for RVSM flight fails, follow these initial reactions. Notify ATC and maintain your cleared flight level to the extent possible while evaluating the situation. Watch for conflicting traffic both visually and by reference to TCAS if equipped. Alert nearby aircraft by illuminating exterior lights, commensurate with aircraft limitations. For this situation, cross-check your standby altimeter to see if you can confirm at least one accurately operating primary altimeter. For this example, it appears that the captain's altimeter is the least accurate. Use the first officer's altimeter for aircraft control. Notify ATC that you are operating with a single primary altimeter. Don't forget to change your Mode C reference. ATC will acknowledge your situation. If both primary altimeters fail, notify ATC that you are unable RVSM due equipment. Unless operational situations dictate otherwise, you must vacate RVSM airspace. The controller will provide you with 2,000 feet vertical separation or an appropriate horizontal separation until you are clear of RVSM. Remember, failure of your automatic altitude control system, altitude alerter, or transponder also constitutes an unable RVSM situation. Next, we'll look at contingencies based on weather, such as severe turbulence or mountain wave activity. Mountain wave activity refers to the cascading flow of air formed above and downwind of mountain ranges. The strong vertical component of this moving air can compromise the aircraft's ability to maintain altitude in RVSM airspace. Indications of mountain wave activity include altitude excursions and airspeed fluctuations with or without associated turbulence. Mountain waves can also cause pitch and trim changes to maintain altitude with accompanying airspeed fluctuations. If you encounter small altitude deviations associated with the weather, notify ATC of the location and magnitude and consider a change in your flight level or routing. ATC will advise you of traffic and issue PIREPs to other aircraft. However, if you encounter significant altitude deviations of approximately 200 feet or greater, notify ATC and state that you are unable RVSM due turbulence or due mountain wave as appropriate. The controller will advise you of conflicting traffic and provide vectors to aircraft to avoid merging targets. As before, consider a change in your flight level or a new route to avoid the area of mountain waves or turbulence. Because of the reduced separation, wake turbulence avoidance may be necessary. Wake turbulence can occur in the vicinity of aircraft climbing or descending through your altitude. Be aware that aircraft 1,000 feet above you can produce a trail of wake turbulence from 10 to 30 miles behind it. If you encounter or anticipate wake turbulence in RVSM airspace, you can request a vector, an altitude change, or, if properly equipped, a lateral offset. In domestic U.S. airspace, pilots must request a clearance to fly a lateral offset. Strategic lateral offsets flown in oceanic airspace do not apply. Note that offsets of approximately one wingspan upwind can be sufficient to move the aircraft out of the preceding aircraft's wake turbulence vortex. Time constraints during an emergency could force you to deviate from your route without a clearance. Diversion contingencies have been established for loss of aircraft performance, pressurization failure, hazardous weather, or loss of navigation capability. In this topic, we'll cover some useful guidelines for making the necessary route and altitude deviations. Whenever possible, try to obtain an ATC clearance prior to deviating from your route or altitude. If prior clearance cannot be obtained, then broadcast your position and intentions to other aircraft. Turn on all exterior lights and watch for traffic. Next, we'll discuss three contingency examples. These are based on whether or not the airplane is able to maintain its cleared flight level and if you need to divert across the flow of traffic. Remember, all possible contingencies cannot be planned for, so these procedures are for guidance only. Consult the references for your airspace for possible differences. In this first example, let's examine a contingency where the airplane is able to maintain its assigned flight level. This diversion might be due to hazardous weather or loss of navigational or separation performance. The initial action, when unable to receive or accept an ATC clearance, is to leave the assigned airway or track by turning 90 degrees to the left or right whenever possible. Subsequent action should be to acquire and maintain a laterally offset track to your original route. A lateral offset of 15 nautical miles in that airspace airways will place you away from normal traffic areas. If you're flying a published airway in the Pacific, a 25 nautical mile offset will place you between adjacent airways. The next subsequent action is to climb or descend to an altitude that is offset from normal traffic use. If within RVSM airspace, your altitude change would be 500 feet. If outside RVSM airspace, climb or descend 1,000 feet. The exception to this is if you are flying at the boundary altitudes for RVSM airspace. For example, if deviating from flight level 410, a 1,000-foot climb or 500-foot descent would be appropriate. Likewise, the reverse is true if deviating from the lowest RVSM altitude. The next example is when the airplane is unable to maintain its assigned flight level. This diversion might be due to loss of aircraft performance or pressurization failure. Your initial action should be to minimize the descent rate to avoid possible traffic below you. Next, make a 90-degree turn while descending. Plan to intercept an offset from your original course as described earlier. When conditions allow, maintain an appropriate offset altitude. In this last example, we'll look at a diversion that takes you across prevailing traffic to your alternate airport. Your initial action should be to first turn in the direction of your alternate and acquire the proper route offset. Next, make a climb or descent to take you away from high traffic altitudes. Finally, proceed to your alternate airport.